Let's look at this section on formulas, and we'll do a couple different things. We're going to use formulas that are already given to us, and then we'll plug in numbers to try to solve for a particular value, or maybe it will all be letters and we just want to kind of rearrange that formula. Both of those we will address in this lesson. Now, one of the things you do want to be aware of is there is a formula sheet provided on the exam, and so you can find that in Canvas modules if you like to kind of see that as you go so you know what formulas will be provided. All right, I thought this was a good problem for us to start with because it lists a bunch of the formulas, and it actually was a multiple choice to start with. We're looking for the area of a trapezoid. Actually, we know the area of the trapezoid. It's 48 square meters. We know one of the bases is 4 and the other one is 8. You can see that's already indicated in the picture. We want to find the height. We're looking for the height here. The first thing that we want to acknowledge is which formula would be the correct formula for the area of a trapezoid. And so of this whole list, and I kind of included this list because we'll use some of these different formulas throughout this lesson. But this one right here is the formula that we want for the area of a trapezoid. So what I'm going to do is I'm going to take that formula and I'm going to use it. So it's the area of a trapezoid is 1/2 times the height times the sum of the two bases. So let's fill in everything we know. We already know that the area is 48 times 1/2 times the height. That's what we're looking for. So I'm going to leave that as an H. But we know the B and the C, the two bases. One of the bases is 4 and the other base is 8. So I'm going to add those up. Now, there's a couple things that you can do here. This 1/2 is somewhat problematic. So there's a couple things. Let me show you both ways, and then you pick what you like the best. You can leave the 1/2 there and just go with 48 equals 1/2 times H times 4 plus 8 is 12. Now, when you multiply numbers, it really doesn't matter the order that you multiply them. If you take 4 times 5, that's the same as 5 times 4. So what I have is a 1/2 times an H times a 12. I could switch those around and it wouldn't matter. So we could do a 1/2 times a 12 times an H. The reason I would do that is maybe so I could go ahead and multiply the 1/2 times 12. Half of 12 is 6. So it just becomes 6 times H. Divide by 6. So it looks like our height should be 8 and we are measuring in meters. So that would be my answer. Now this one worked out beautifully to do that. Let me show you real quick one other way. Sometimes what we'll do is we will try to get rid of the fraction right off the bat. So I'd have the 48, I should have written this, okay, 1/2 times the H times the 4 plus 8. I would start off that way, but maybe I would just right off the bat multiply both sides times 2 over 1. If I multiply by the reciprocal, that fraction can go away. On the left side, I'm left with a 2 times 48. And then I have this H times 12, divide by the 12. Oh, H is 8. Okay, so we get to the same place, but I wanted to show you this method of multiplying by the reciprocal because we do actually do that quite often. All right, let's keep moving. All right, here's another one. It says solve the following equation. Express your answer as an integer, a simplified fraction, or a decimal rounded to 2 places. So no idea how this is going to play out. Let's see. A rectangular shaped parking lot is supposed to have a perimeter of 620 yards. So they're giving me a perimeter, so I'm looking for my perimeter formula for a rectangle. All right, it's back on that previous slide. It's on your formula sheet. The perimeter of a rectangle is 2 times the length plus 2 times the width. Remember that perimeter is really just the distance around, and so you have 2 lengths and you have 2 widths that you would have to add all up. So that's where that formula comes from. We already know that the perimeter is supposed to be 620. So I could fill that in. I know perimeter is 620. The width must be 76 yards because of building code. Okay, so if the width is 76, I can fill that in, but I'm looking for that length. So in my formula, I'll leave the 2 times L, but I'm going to replace the W with a 76. And then let's go ahead and take that 76 times 2. I think that's 152. And now we're going to just do some solving. I need to move the 152 over to the other side with the 620. So I'm going to subtract 152. $468 equals 2L, divide by 2. And what are we? We're in yards, so that's 234 yards. All right, let's take a look at this example. This one is not from your formula sheet, but the formula is incorporated in the problem. The value of an item after t years is given by the following formula, assuming linear depreciation. So it's going to go down at a steady rate. And it says C is the original cost, R is the rate of depreciation expressed as a decimal, and they give us some information. So we bought this car for $41,666. All right, that seems like that's going to be the original cost, so that's going to be our C. It depreciates at a rate of 12%, so that's our R. And the question is, what will the value be after 33 months? So I'm looking for V. And so the C again was the 41,667 minus 41,667 again, times my rate. The rate was 12%, but if you need that as a decimal, you move your decimal to the left 2 places. And then the time, this is a little bit sneaky. The time is, it says 33 months, but up here the formula has to be in years. So you have to convert your 33 months into years. And the quickest way to probably do that is just do a 33 and divide it by 12 to see how many years that is. Now that's not going to come out perfect, but it doesn't come out too bad. It's 2.75. Now you could enter this just left to right in your calculator if you're very careful. Some people like to go ahead and condense some things. All of this is being multiplied, and the order of operations says that I should be doing that first. So maybe if you want to break this up into parts, you could go ahead and multiply that all together. And when I do that, I get $13,750.11. And now if I go ahead and subtract, I'm left with $27,916. Wait, what does it want to the nearest cent? So I'm going 0.89, and that's the value of the item at this point. All right, hopefully that was a pretty good sampling of some different types of formulas that you'll come across where you're plugging in numbers. Now I'm going to move on to the next type of problem, and this is just where everything is a variable and you're trying to isolate one of the variables. You're supposed to solve the formula for that variable. Now, this formula that we're going to start with is a perimeter formula. This is the perimeter of a triangle. Ultimately, you're just going to add up all 3 sides of the triangle, and that's going to get you the perimeter. Now, this is a great formula if you're always looking for the perimeter. But on some of those previous examples, if I'm trying to solve for like maybe a variable in the middle, or in this case it says solve for A, and I already know what my perimeter is, and I know the B and the C, and I have to solve for the A. And if I was going to repeat that process a lot of times, it'd sure be nice to have a formula that said A equals instead of a formula that says P equals. So that's what we're working on, is trying to rearrange the formula so that a different variable is solved for. In this case, A. So we're going to do everything we can to sit there and isolate the A. So it's adding B. So I'm going to undo the plus B and I'm going to subtract B, but I got to do it on both sides of the equation. And while I'm at it, this plus C, I don't really want that either, so I'm going to do a minus C, and I've got to have a minus C on the left side as well. Now those are going to isolate perfectly so that that A is all by itself, and then I'm going to have on the left side here a P, and I'm going to subtract a B, and I'm going to subtract a C. And so if you wanted to rearrange it, if I wanted this formula and I was looking for A, then I could do perimeter minus the B minus the C, and that would give me my A value. All right, let's try some different types like this. This one, instead of having a bunch of addition on it, has a bunch of multiplication. So we have the I equals PRT, and we're supposed to isolate the R and get it solved for R. And you can see that the R is being multiplied by the P and the T. So I want to divide by the P and the T. Now this works beautifully since all you're doing is multiplying. If you start combining multiplication with addition, you have to be a little bit careful about doing everything in one step. But this is a classic scenario where you can divide both by the P and the T at the same time, since the only thing happening is that multiplication. So when you divide by P and divide by T, you have your R all by itself. I'm going to have to take my interest and divide it by my principal and divide it by my rate. That's that formula we used earlier, or it's on your formula sheet. If you like to have the isolated letter on the left, I tend to, then I rearrange it. All right, this one's a little sneakier. It says B is equal to A over T, and I'm supposed to isolate the T. The problem is that the T is down in the denominator. And I don't want my T to be in the denominator. I don't want it to be fractional. I just want T to be by itself. So the very first thing I'm going to do on this problem, I'm going to rewrite it over here, is I'm going to get rid of the fraction. So if A is being divided by T, I'm going to multiply both sides times T. Because dividing by T and multiplying by T, that will undo each other. You can also think of it like a T over 1. These T's would cancel, and all you have left is the A. But your T is now over here on the left side. Now that's okay, we didn't get rid of the T, but in fact we're trying to isolate the T, but we at least got rid of our fractions. So now I'm looking at this problem like I'm trying to get T all by itself, and it's being multiplied by B. Well, let's undo multiply by B by dividing by B. So T is going to equal to A over B. And I know I'm back to a fraction, but that's okay because I have the T isolated. All right, here's another one, just a little bit fancier than that last one. I'm trying to solve the formula for M. I still have that darn fraction going on that's a little bit messy, but I also have two things here in the denominator. That's okay. Again, since they're tucked in together, I can get rid of them at the same time. I'm going to multiply both sides times HM. So I have H times M times G equals V. Now I'm trying to get the M by itself, so when I look at it, oh, M is being multiplied by H and it's being multiplied by G. Shall we divide by both of those? So now the M is by itself, and it would equal V over HG. All right, are you getting the hang of it? I'm almost done. All right, this one has an X and a Y in it, and we want to solve the equation for X. To get the X by itself, I can see that I got a couple things going on. I have some multiplication going on here and here, and it's tucked in here with this addition. So there's a few things that I need to be rid of in order to get this X by itself. I need to get rid of the 9. But I also need to get rid of this whole term here. And I always think of it like I try to work my way towards the X. So I deal with the things that are farther out first. So this plus 7y, I really don't want that over here. So I'm going to subtract 7y on both sides of the equation. That will help get rid of that term. And then I'm going to go ahead and write 12 minus 7y. They aren't like terms. I can't really subtract them. And I guess that's what's different here is I'm moving stuff back and forth, but the y stays there and we don't always get to like combine them together. All right, so then my next step is to get rid of this 9, and it's being multiplied. So I'm going to divide by 9. It's going to work great here. Over here, I have to divide everything by 9. It doesn't look near as pretty. Well, I didn't promise it was going to get better looking. It's just, different looking. So 12 minus 7y, and then divide it by 9, and that would get you your X value. All right, I have one more. It's a little fancier, still solving for X here, but it's caught up inside of some stuff. I have a couple ways that we can get rid of that 5 there. Actually, I think I'm just going to show one way because it's probably the way that creates the fewest amount of errors. The first thing I want to do is get rid of those parentheses, so I'm going to distribute my 5 to get rid of those parentheses. So that's going to be 5x minus 55 over 4. And then I have that fraction. Remember what we've been doing. To get rid of the fraction, I have to multiply by that denominator to make it go away. You have to do it on both sides. So the divide by 4 with the times 4 undo each other. Now that I have no fractions, I'm going to work on isolating that x. So just like last time, I have this 5 here, but I also have this minus 55. And this is further out, so let's get rid of that. First, we're going to bring it over. It's a minus 55, so I'm going to add 55. Just like last time, this 4r and this 55, those aren't like terms. There's nothing I'm going to do with them other than write them next to each other. 4r plus 55 equals, on the right side, the 55 went away, but the 5x is still there. And then my last step to get the x by itself is to undo this times 5. I'm going to divide by 5. I'm going to divide both sides by 5. And then just because I'm kind of OCD this way, I'm going to put my x on the left, and it's going to equal 4r plus 55 all over 5. And then you can just leave it like that. We have other ways of writing it, but I'm going to leave it. All right. Hope that was a nice sampling that kind of helps you with some of those problems on 7-5. Good luck.